Hey, so I'm going to be doing what is bivariate data. Hope I pronounced that right. Probably didn't. Scatterplots help us track and visualize the information. It also helps us see if there is a pattern. Let's say Bob and his friends work at a store with a tip jar. They decided to compare how much they made in tips last week. Here's a table with how much Bob and his 6 friends made. So you can see the X is the hours worked and Y is tips in dollars. So, when you go on the calculator, you go to list and spreadsheets down here. To make a scatter plot, just gonna put in our X, which is hours worked, and our Y. Sorry, there's a lot of allergies going around. So for hours worked, one person worked for 1 hour, another friend worked for 2 hours, another person worked for 4 hours, and so on. And respectively, they made $2, 2.5, 3.5. So this is our data right now. Now we go back here and go to data and statistics now. It shows us all of our points. Just go over here, click to add variable X on the X-axis and Y on the Y-axis. And this is our scatter plot. Question number 1. Is there a pattern? A, yes. B, no. C, not enough information given. D, none of the above. Yeah, that's right. The answer is A. Yes, there is a pattern. Now, the regression line helps us approximate and take an educated guess at what possible info would be. On the calculator, to make a regression line, you would go to Menu, Analyze, Regression, Show Linear MX plus B. This regression line is basically an average of the points. And as you could see on the calculator, this was our equation. Question 2. What if Bob were to work for 12 hours? How much money would he make in tips then? There are 2 different ways to do them, and so for the first one, you would go to graph and then just input the equation 0.9479117. Oops. 947917 times x plus 0.4375. Enter, and that's our line. Then you could go Control T to see the table. At X 12 hours worked, he would most likely make about 11.8 cents in tips. So, and then another way to do it is just replace the X with what you want to figure out, because X is a variable for number of hours. So you could just kind of shorten it down, 0.9412 for 12 hours plus 0.4375. 0.43, and that would give you 11.71, which is pretty close, especially since we are rounding it up. Well, not rounding it up, but simplifying it. Wait. Shortening it. I forgot what it was. Oh man. Right. So down here we can write 11.71 dollars, or you could even write 0.81. It's essentially the same. Correlation coefficient is used to see if there is a positive, negative, or no correlation within the data. It is used to show how strong the correlation is. If one variable is increasing and the other is decreasing, there is a negative correlation. If both variables are increasing, then there is a positive correlation. If there is no pattern at all, there is no correlation. The correlation coefficient shows how close to a line a group of data is. We can use -1 is less than or equal to r is less than or equal to 1. If r equals the correlation coefficient, if r is greater than 0, it would be a positive correlation. If r is less than 0, there would be a negative correlation. So, to find the correlation coefficient, you'd go back to your data. Come on. What? Right here. Okay. Go to menu, statistics, stat calculations, two variable statistics. Make your x list x, obviously, and then y list y. Wait, oops. My mistake, we do not go to two variable statistics. Escape, cancel. Go to menu, statistics, stat calculations, linear regression, mx plus b. X and Y for X and Y list, obviously. Oops. And just click OK. And we have a bunch of data here. As I showed you earlier, R would be the correlation coefficient. Oh my gosh. So this is our correlation coefficient, 0.938, etc. As we saw earlier, the closer it is to 1, the closer it is to the line. So our line is pretty good. It shows the numbers very well, and it is a very strong positive correlation. The numbers are generally pretty close to each other, and it does not vary much at all. Question 3, is there a positive or negative correlation? I actually just answered that. Yes, there would be a positive correlation. This is because our correlation coefficient is greater than 0 and close to 1. It doesn't need to be closer to 1 for it to be positive, but the more it is, the less the numbers vary and the closer it is to the line. Question 4. Knowing this, if there is a correlation coefficient 7.8, is there a positive or negative correlation? There is a positive correlation because 7.8 is greater than 0. Now for the hardest question, question 5. If given this table, find the correlation coefficient. You should pause the video now to do this. If you got 0.995, etc., you were right. Some people make the mistake of where they think correlation causes causation, but this is not necessarily true.